Okay, ready to go back. So yeah, I thought a little bit with basic neural nets. Now I think I'm ready to present them in front of an audience. So yeah, still the plan is to do in the end to implement transformers from scratch in Jax, but I want to focus on understanding the basics. So like in transformer we have let's see, in transformers we have these basic equations like attention, right, or multi-head attention. We have these feed-forward nets, and I want to play a little bit with those just to make 100% sure that I understand what's going on there. So yeah, I just want to focus first on getting a hang of basics. So I did it before, it's on my GitHub, but I'm going to do some super basic neural nets from scratch just to refresh these things for myself. Okay, so we take numpy, right, and we're going to predict or learn function sinus. So we will take first x sinus x, and then we're going to do something like this, and then minimize loss. So yeah, excuse me. Let's take batch size of 256 because why not? And then we will do for let's do like x equals numpy random uniform from -4 to 4, and then we will do size is batch size, right, and 1, and then y will be just sinus this. We will write a neural network that does this. So yeah, let's do basic equations for the neural net. Okay, so it will be hidden. We'll have one layer, and the size of this hidden layer will be 32. And then for this, so the equations will be something like z will be equal to a times x, and then plus some b, and then maybe something like this, and then will be nonlinearity times z, maybe real, because also why not, and then we'll have y hat equals a2 times h times b2, something like this, right? So super basic neural net. So yeah, let's draw a1. Maybe initialization size. So yeah, let's do something small. Random normal. So input size is 1, and then hidden size is this, and then b1 times init size. Then b1 is the same thing but of size hidden size, right? Yeah, because this will be like 32, right? And then when it comes to a2 and b2, this will be 1, and this will be just opposite. And then equations will go something like z equals, so x is of size batch size times 1, so we do this times a1 plus b1, and then h is relu of, okay, we need relu, so relu is relu is what? Np max. We'll do it like this, where x is greater than 0 and it's x, and then where it's smaller than 0 is 0. And we will need the real in a second, but yeah, let's not go get too ahead of ourselves, right? So then we have h, and then y hat is h times this times a2 times this. Okay. Let's see if it works. Okay. What's the shape of this guy? Perfect, perfect. Okay, then, no, this is so distracting, so yeah, I will just close it. Can I make it like a little bit smaller? Just like a little bit too huge, right? Anyway. Yeah. So now we want to say, okay, so loss is just L2 loss. So y hat minus y, right, squared. And then d loss of dy hat is just minus just this. Okay, now here comes the interesting part. We need d loss of d everything. So d b2 is just the same, the very same thing. Just the, like, imagine some y hat is a little bit too big. Like, how do we change b2 such that loss is a little bit worse? Because this is the intuition of the gradient, right? Like, how do we increase the loss a little bit, right? So we would need to, like, if y hat is too much, just increase the b2. So if this is positive, we like make it a little bit more, right? So it's like direct. Yeah, so we want to take average of this, right? And then we take the loss of a2. So what's that? What's that? Let's see. Okay, so we know, this is so confusing, but anyway, we'll have to roll with it. We know that y hat is influenced directly by this a2, and we know it's like a linear function of h, right? So h has to come into the equation somehow, and this y hat, like this, has to come into the equation somehow, but only these two things, because it's just linear function. So yeah, let's just print shapes of those. So this will be like what? This will be, let's predict, this will be like batch times 32, right? Because of the build. Batch times hidden size. Yeah, batch times hidden size, very good. And this thing, it will be batch times 1, right? And we want to get something that's 256 by x by 1. So yeah, let's just like start constructing the things. So it's like batch times hidden size, right? Batch times 1, let's call it 1. And we want to have batch batch hidden 1, and then we will flatten the batch size, right? So yeah, let's do this, see what comes out. Yeah, we need so that was hidden, and then that was this guy. Okay, so shape makes sense, right? Okay, let's copy it because it was an error. Yeah. So again, we do this, shape, it's perfect, and then shape 30 to 1, yeah, and this is like same as shape of A2, which is exactly what we want. Perfect. So that's amazing. Okay, so we're done computing the weights for the output layer A2, B2, and now what? Now we want to, I will just turn off debug because it's too confusing. So now we will want to compute the rest. So if we, let's first figure out what's d loss over dh, right? So like we need to project back via A2, right? Because y hat is influenced by linear weights of A2. So y hat is influenced by h. But basically it's like this, right? Like d loss dl d loss by dh equals d loss over dy hat times dy hat over dh. So we know this. That's it, right? This is the one. And dy h over dh. So dy hat is influenced by the hat dh only through this. Just have the equation right here. It's all linear. So what we're going to do is we're going to do it like this, einsam, right? So we're going to need d loss hat, and we're going to need a. Now we're going to count dimensions because it's all linear, so just by counting the dimensions we'll be able to turn everything. So d loss hat is like b and 1, right? Yes. So it's like 30 times or whatever the batch size was. Yeah, 256, yeah. It's 256 times 1. And then A2 is hidden by 1. And what we want to get is batch by hidden. So can it make, yeah. Okay, and that's it. Just see if it works. Bang, this. Okay, so shape of this guy has to be batch times hidden. So 256 by 32, and it is. Okay. It's so easy with this einsum. No. Anyway, yeah. I didn't start the